Hello guys, so today we are going to discuss this problem. It's about finding the longest arithmetic subsequence of given difference. So first of all, what is a subsequence? So subsequence is a sequence out of an array or a string which is non-contiguous, which can be non-contiguous, while substring is always contiguous. So the problem is that out of the given array, we are given a difference and we have to find the length of the longest arithmetic progression. So here, as you can see, this is a AP whose difference is 1 and hence its length is 4. In this case, with difference of 1, there is no AP, right? So we return 1 because every element is a arithmetic progression only. So let's see this case. In this case, we have our longest. Let me copy this and show it to you separately. Okay. So here in this case, we have let's see with -2 difference, how many arithmetic progressions are there. So with 1, we do not have any arithmetic progression starting with 1 because it will be something as 1 and then -1, which is not there. With 5, how many arithmetic progressions are there? We have 1, 5, then we have 3, and we have 1. So this is of length 3. This is of length 3, right? Now let us take with 7. With 7, we have 7, 5, then we have this 3 included, and this one, right? So this arithmetic progression is of length 4, right? So as we can see, this is a subsequence which is non-contiguous. Um, and do we have any other arithmetic progression as well? Let's see that. So with difference 2, let me take green. So we have with 8 we do not have because 6 is not there. With 5 we have already taken 3. With 3 we have 3 and 1 we have already taken. With 4 we have 4 and 2 with difference of 2. So its length is 2. So how we are going to solve it? So uh, okay, let me, where is sequence arithmetic progression, forming arithmetic progression. Okay, let me explain you here itself. Uh, this will be easy. Okay, so here, um, okay, here what we have is we have the array and indexes noted below. So we'll be taking a hash map. So we'll have a hash map in which the key will be equal to the element, the present element in the array, and value will be equal to the length of longest AP arithmetic progression till this element, right? And we are going to like increment this. So let's see how. So at element 1, we'll have an entry as 1 1 because, and what we are going to search in the hash map, we are going to search element minus difference. This will we will search in map, hash map. So in this case, in our case, difference is -2. So we'll search 1 minus minus 2. Do we have 1 minus minus 2, which is equal to 3 in the hash map? So initially hash map was empty at this element. So no, we do not have it. So hence we made value as 1. That is, we inserted this in the hash map, value as 1, and uh, the longest AP till this element is also 1 because this is also AP. Now on the next element, we'll search 5 minus minus 2, which is equal to 7, right? Do we have 7 in the AP in the hash map? No, because we only have one element. So 5 and 1. Till this element 5, we have only one AP, that is the element itself. Then we'll go to element 7. We'll search 7 minus minus 2, which is 9. Do we have 9 in the hash map? So hash map has these two entries. No. So that's why 7 and 1. Then we go at 8 in array 8. We'll search 8 minus minus 2. Do we have 10 in the hash map? No, because hash map has these three entries, right? So we'll make till 8. We have only one AP, which is whose value is 1. Now at this element, that is at 5, so we'll search 5 minus minus 2, which is 7. Do we have 7 in the hash map? Yes, we found 7 in the hash map, whose value is 1. So what we'll make till this 5, we have a AP of length 2. So we'll take this one and we'll add 1 to it, and we'll have this 5 2. Now when we are at element 3, so we'll search 3 minus minus 2 5. Do we have 5 in the hash map? Yes, we have 5 in the hash map. And what we'll do, till this element 3, so this is the element, right? We know this key is the element. We will what is the value at the key 5? So we have 2, so we'll add 1 to this, and we'll make it 383. So what does this signify? This signify that till this element, that is till this element, we have a arithmetic progression of length 3. Till this 5, we have arithmetic progression of length 2, and till this one, we have a arithmetic progression of length 1, right? So on, uh, for this 2 will become 2, because for this 2, what we'll find here, we'll find 2 minus minus 2, which is 4. Do we have a element 4 in uh, the array? Yes, we find it, whose value is 1. So we'll increment it by 1, and at last we'll search 1 minus minus 2. Do we have 3 in the array, in this hash map? Yes, so we have a 3 which has a value as 3. This 3 signifies that we have a arithmetic progression till this element as 3, which is 7 5 and 3, right? Difference of minus 1, minus 2, minus 2, minus 2, and here we'll have 1 comma 4, right? Because this will 3 plus 1 will become 4. So this is how we can solve this problem in ON time complexity and ON space. So let's quickly see the code. So what we are doing is we are taking a hash map, we are iterating through the array. In the hash map, unordered map, we are searching the difference. Then we, if we do not have an entry, that is, if we do not have an entry, in else case, we are inserting key, that is element and 1, which we have seen that we are doing in these cases 8171. But if we found an entry in the unordered map, so we'll take the value, increment it by 1. In this case, for example, 5 2, we found 7, so we take the value and increment it by 1, it makes 2. And we will also take the longest uh, of longest and the value, and finally we are going to return the longest. So this is a very simple question, but a tricky one as well, because how to use the hash map to store the difference is the key. So thanks a lot. Have a good day. Bye.